Okay, so today we're going to sit here and we're going to cover the second part of the 6.7 notes that we didn't get the chance to finish on Friday. So when it wants you to write a recursive rule for each sequence, you have to first determine what type of sequence it is, okay? So you need to ask yourself, what type is this? So if it's an arithmetic sequence, it is going to be adding by the same amount every time, or you can also think of it as it can subtract by the same amount every time, but we consider that adding by a negative number. If it is geometric, it's going to be multiplying by the same amount every time. So when we look at this clearly seems to be going up every single time by 12. So it's adding by 12 each time, and that can be verified with a calculator. So therefore, since it's going up by the same amount, we would say that it is an arithmetic sequence. So the arithmetic recursive rule we can find on our notes that we started on the other day. And the recursive rule says you take a sub n minus 1, that means the previous term, plus the common difference. So we always define the first term. So we always put a sub 1 equals. And the first term is just the first one written in the sequence. So it equals negative 30. Then we go ahead and we do our formula. So we put a sub n equals a sub n minus 1. And then our common difference is how much it's changing by every time. That's d right there. So this is our answer. So now on part B over here, it is saying how is it changing. I can tell that it's dividing by 5 each time, but we always want to write it as a multiplication. So we're going to say that it is multiplying times 1/5. Since it's multiplying by the same thing every time, it is going to be geometric. So for geometric, we go ahead and write the recursive rule. Our formula for geometric says that it's a sub n equals r times a sub n minus 1. R is the common ratio. So in our case, r is 1/5. As always, we have to give our first term. So we're going to say our first term, a sub 1, is 500. And then for our equation, we write 1/5 times a sub n minus 1. That means take 1/5 times the term before it, or the previous term. And that would be our answer for a geometric rule. Okay, this is more practice on this. So rather than give you just tons of practice, I'm just going to go over 8 and 9. If you need more practice, asking your instructor about 5, 6, and 7 in class would be a great plan. So let's look at number 8 first. I really wanted to point out number 8 because if you notice, it's going positive, negative every time. So that indicates to me that this has to be being multiplied by a negative number. So I'm very confident that it's a negative number. So when I see this, I see that it is going down, it's dividing by 4. So we would call that 1/4, but then we make it a negative because that accounts for the change in sign. So that means that our common ratio is negative 1/4, and our first term is 128. So for our equation, we would state your first term, a sub 1 equals 128, and then do the formula. A sub n equals, now since this is geometric because it's multiplying, we would do our common ratio, which was negative 1/4 times a sub n minus 1, which is the previous term, and that would be our answer. Now on number 8, it says write a recursive rule for the height. Now if we look at this, keep in mind what you're looking at is its specific height, not just the months. So from 2 to 3.5 feet, it is adding 1.5 feet. From 3.5 to 5, once again, it's adding 1.5, and from 5 to 6.5, it's adding 1.5. So since it's adding, it's arithmetic. The common difference is 1.5, and the first term is 2, because it was 2 feet during the first month. So what would we do here is we, of course, first state the first term, so a sub 1 equals 2, and then go through our recursive formula says you take a sub n equals a sub n minus 1, and then it's plus your common difference, so plus 1.5. So those are just extra practice of what we learned on the previous slide. Okay, on this slide, this is different. This is saying that we have the recursive rule and we're writing the explicit rule. So once again, first figure out what type it is. Do you see how this is a sub n minus 1 minus number? That tells me that this is arithmetic because I know that it is not multiplying by something. So it has the first term right here, and then right here, this is going to be your common difference. So then our explicit rule for arithmetic, this comes from chapter 4, we've known it previously, and I had you write it down on the first day of notes. So the explicit rule is this. If you don't have it written down, definitely write it down now. So we would plug in everything we know. We know the first term is 25. The formula is n minus 1. And then I'm going to multiply times negative 10. From there, I just simplify. So I'm going to distribute the negative 10. So I have 25, negative 10 times n, and negative 10 times negative 1 is positive 10. So when you simplify, what you get is negative 10n, and then 25 plus 10 is plus 35. And that is the explicit rule for this recursive rule. Now looking at B, this is definitely geometric, and how I know is I see it is multiplying. So right here, the common ratio is multiplying. This is the R. This, of course, is the A sub 1. So once again, we learned this equation in the previous section, section 6.6. And we know that the equation for the explicit rule, not the recursive rule, this is the recursive rule, the explicit rule equation is A sub 1 times R to the n minus 1. So from here, we just fill in what we know. We know A sub 1 is 19.6, R is negative 0.5 to the n minus 1 power. And that is our answer. So down here on part A, this is different because this is going from the recursive rule. It's finding the recursive rule going from the explicit rule. Now looking at this, I know that this is definitely an arithmetic sequence. And how I know it's arithmetic is because I see that n is not in the power. So you see over here where n is in the exponent? I am sure that that is geometric based on how up here n minus 1 is in the exponent. That tells me geometric. So since this is arithmetic, I need to know two things. I need my first term and I need my common difference. So how I can find my common difference is I can find it from the coefficient of n. It will always be right there. The reason is going into this rule, what the formula said was take the difference times n and times negative 1. So I know it will always be in front of the n. So that's my common difference. Now to find the first term, we just plug in a 1 for n, and we find out that that's negative 2 plus 3 is 1. So our first term is 1, my common difference is negative 2. So we're trying to write the recursive rule. The recursive rule for arithmetic is a sub n equals a sub n minus 1 plus d. So let's go ahead every time. Remember, if it's recursive, you have to state your first term. Your first term is 1, and then you give your recursive formula. A sub n minus 1, remember the difference was negative 2, so you can put plus negative 2, or most people will just put minus 2. Now, on part B, as we talked about, it's geometric. We already established that. So what we need to know is we need to know its common ratio, and we need to know its first term. So when you look at the form up here that we had, this was the first term. So here, this is a sub 1 is negative 3. The ratio was inside of the parentheses, so 2 is our ratio. So now we look at our rule for our recursive equation, which is a sub n equals the common ratio times a sub n minus 1. So as always, state your first term. The first term is negative 3. And then show just the common ratio times a sub n minus 1. And all of this combined is your correct answer. All right, looking at the next slide, this is just extra practice. So at this point, you've seen examples just like these on the previous slide. This would be a great time to just go ahead and try them out and see how it goes. But if you need more help, please ask your instructor. They are exactly the same as what we just did on this previous slide. Okay, this sequence is actually quite a bit harder. You initially look at it and kind of think, okay, these are clearly going up, but it's a little hard to determine what's happening. So let's look at this in depth. It says that we have this sequence shown, so we need to see what is happening. Now, because I've seen this sequence a lot, this is actually a very famous sequence, which we'll talk about later. But because I've seen it a lot, I can really easily tell what's happening. So if you notice, to get 2, there's no specific rule. Like from here, you add 0, you add 1, you add 2, you add 1 again, then you add 2, then you add 3. It's a little difficult to figure out a pattern until you look at it and you see that what you are actually doing is you are taking the previous 2 numbers and adding them. So 1 plus 1 is 2. So then to get the next numbers, you would get 1 plus 2 is 3. So to get 5, you would do 2 plus 3 is 5. So before we get into the recursive rule, let's go ahead and just write the next 3 terms because I almost find that easier to do. And then we will go ahead and we will figure out our recursive rule. So remember, how we got 8 was by taking 3 plus 5. So here we're going to do 5 plus 8, which when we do that, we get 13. So this will be the previous terms added. So 8 plus 13 is going to be 21. And then once again, we're going to do 13 plus 21 to get the next term, and that's going to be 34. So there's the next 3 terms in the sequence. So the recursive rule, as always, the easy part is stating the first term. That's not a big deal. So on this one, because we're always adding the 2 previous terms, right, we need to go ahead and we need to state the first 2 terms. So I'm going to take a sub 1 is 1 and a sub 2 is 1. That's the first term and the second term. Now the only reason I had to list both was because I'm adding 2 different terms to find the next one. So I need at least the first 2 to be able to find the third term. So what I did after that, to find every term after that, I took the term 2 before it and then the term right before it, and I added them together. Now I know the term right before it is n minus 1. So how you would describe the term 2 places before it, it's 2 places back, so it's n minus 2. So that's saying the term 2 places before and the term right before, and you add them together. Now I know this is really confusing. This is a much more advanced sequence, but it's definitely important that we're still exposed to it and try a few of them. There's not tons on your homework, but there are a couple so that you can try them out and just see how it goes. Okay, so over here, this one's wanting us to write the recursive rule and then write the next 3 terms of the sequence. So you can tell this one's looking very similar to the last one. We're taking and we're doing 5 plus 6 to get 11, and then we're doing 6 plus 11 to get 17, 11 plus 17 to get 28, and so on. So I know that if I define the first 2 terms, because I'm using 2 terms to get the next thing, not just multiplying by the term before or adding to the term before. So if I define the first 2 terms, and then this is very, very similar to the last one, I'm taking the term 2 before it, so I'm going to do n minus 2, plus the term right before it, so I'm going to do n minus 1. And that's going to be the first part of my answer, although I still need to find the next 3 terms, okay? So we have 5, 6, 11, 17, 28. So now I need these 3 terms. So what I did to get 28 was I took 11 plus 17. So in the next one, I'm going to do 17 plus 28. So when I type that into a calculator, I get 45. To find the next term, I'm going to do 28 plus 45. Once again, it's completely fine to use your calculator. You get 73. So then I'm going to do 45 plus 73, and I get 118. And those are the next 3 terms in my sequence. Okay, this one looks very similar to the last one. You're just adding the 2 terms. So go ahead and try this one. Pause the video and see if you can write this, and then find the next 3 terms. Okay, hopefully you did pause the video. What it looks like we did here is it looks like we took and we have to define the first term and the second term. Remember, why I started finding the first and the second is because of this being a more advanced sequence where it uses both terms. So what I'm doing is I'm taking the previous term, and I would say that I am adding it to the term 2 places before plus the term 1 places before. So that's my equation, and then to get the next 3 terms, I have negative 11 plus negative 18, and so that's going to be negative 29. I'm going to do negative 18 plus negative 29. I'm going to get negative 47. And then negative 29 plus negative 47, and I get negative 76. Like I said, these are definitely more difficult. Okay, let's go ahead and look at 17. 16 is very similar to 17, but I think 17 is just clearer to see. So if we take a look at what's happening here, these are subtracting. And this just takes practice. You will get better with practice about quickly seeing what's happening. Sometimes you just have to look for a pattern, try it out, see if it holds, or maybe it doesn't and you have to try another pattern. But definitely with practice, these get a lot easier. So I can tell that we are taking 4 minus 3, we get 1. 3 minus 1, we get 2. 1 minus 2, we get negative 1. 2 minus negative 1 turns into plus, and we get 3, and so on. So what we're doing is we are taking the term 2 places before the current term. So if I'm on this term, 2 places before, so that's why it's n minus 2. And I am subtracting this time the term right before it. But keep in mind, since I'm using n minus 2 and n minus 1, I really need to define both the first and second terms. So this is my recursive equation for this, and then to find the next 3 terms. So I'm going to go ahead and copy this sequence down so I can show you what's happening. You do not have to copy it down again. I just want to be able to show my work below each number so I can show you how this is occurring. So to find this term, take the term 2 places before it, that's 3, and subtract the term right before it, that's negative 4. So 3 minus negative 4 turns into plus, and we get 7. So to find this term, take the one 2 places before, that's negative 4, and subtract the one right before it, that's 7. So negative 4 minus 7 is negative 11. So here, take the one 2 places before, that's 7, minus the one 1 place before, just right next to it, and that's negative 11, and 7 minus negative 11, sorry, I didn't write that real clear, 7 minus negative 11 is going to turn into plus, and it's going to be 18. So I can tell that this is what's happening on this one. So we will most likely give you pretty clear ones that don't, get extremely confusing and don't use more than 2 numbers recursively. But these are definitely more advanced, and I really encourage you to challenge yourself and see how it goes. So thank you for watching the notes. If you would attempt part of the homework problems, that would be great. We're going to end up having them due on Wednesday.